And I should say that these networks are what we call fractal-like. If you know what a fractal is, it means that if you blow up a small part of the network, it looks like the whole network. Okay, and what this gets to is this last theme, which says that non-normal is the new normal. So let me explain that. Okay, so what is normal? Well, here's the mathematical definition of normal. It's a bell curve. This is called a normal distribution. So this is height, right? Frequency. And this is a nice picture because it shows, like, here are the shortest people, here are the tallest people. And most of the people are in the middle. And actually, there's nobody really out here who's more than, like, 9 feet tall, and nobody really out here, any adult who's less than, like, 2 feet tall or something like that. There's some ends. So what those ends are called is a scale. Height is along a scale. It's a scaled distribution. However, so here's like what we would look at as a simple bell curve kind of thing, which is what that random network's degree distribution looks like. But if we look, what we just saw was something very different, which is does not say that most people are in the middle. Most people are over here at the edge, and there's this very long, what we call the tail. Okay, so these are the hubs that have many, many links. And so this distribution has what's called the long tail. And it's called scale-free because, in principle, there's no end to this tail. So there's no characteristic scale. But this long tail thing is a really important aspect. Mathematically, tail goes to infinity. So it's important also, I'm going to show you a few I'm going to go for about 5 more minutes. Is that okay? I'm going to show you a few plots of real-world distributions, but I want to say that a lot of times people plot this kind of thing by taking the logarithm of both axes. This is like the only math in this talk, really. But if you do that, it turns out that this becomes something like a straight line. So you're going to see some straight lines and all, and those mean that the shape looks like this. So one example of a straight line is the distribution of earthquake magnitudes. Okay, so you know about earthquake magnitude. The magnitude of an earthquake is a logarithmic scale. Each one of these is 10 times more energy than the next. And if you plot the frequency, there's lots and lots of very small earthquakes and very few really big earthquakes. And it falls along this nice